This next video talks all about the nuclear transformation and the concept of half-life. Okay, everything that is radioactive undergoes a half-life. And a half-life is literally how the name suggests. It is the time required for half of the atoms that are the radioactive nuclides to decay. So what that means is you are seeing how many times it decays in half. Now, the time that it takes for an unstable atom to undergo a half-life is specific for that element, and the times widely vary. So it really does depend on what it is. Like beryllium 11, that'll take 13.81 seconds for half of it to decay. That's crazy, okay? It's really, really fast. Carbon 14, 5,715 years. Okay, so if you have some sort of multiple of 5,715 years, you can figure out how old your fossils are. All right, they just measure how much is going to be left. Gold 198 is 2.70 days. Potassium 42, 12.4 hours. So you'll see that these time units widely vary. All right, you have your seconds, you have your years, you have your days, you have hours. It's some sort of time unit. And that's nothing that you would have to memorize. So again, we said carbon 14 is your 5,715 years. Um, your astatine, who we barely talk about in the halogen group, that is going to be 1.6 seconds. Okay, it really, really decays really quickly. Uranium, however, is 4.46 times 10 to the ninth years. That is a billion years for half of it to go away. So that's why using all of those uranium atoms for energy is really bad. Um, plutonium is going to be 2.41 times 10 to the fourth years. That's going to be over thousands of years. I mean, an unbelievable amount of time for this stuff to clean up and get out of the environment. All right, so this right here is going to be your saving grace. Okay, this is a chart that helps you put into perspective how many number of half-lives elapses, like time lapse, goes by, and the fraction that should remain. So when you start, you have 1 out of 1 or 100% of your original nuclide. Now, when one half-life goes by, you have a half or 50%. When two half-lives go by, you have a half of a half, which is 1 times 1 and 2 times 2, 1/4, or 25%. Remember, we're dividing it by 2 each time. If you have 3 half-lives go by, you have a half of a half of a half, or an eighth, okay? Or 12.5%. You have 4 go by, you have a 16th. You have 5 go by, you have a 32nd. You have 6 half-lives would be a 64th. 7 would be 1/28th, so on and so on and so on. So what you can really say is you have 1 over 2 to the nth power. And that's really going to tell you, with n being the number of half-lives that pass. All right, and we're going to get smaller and smaller, smaller, down to as close to 0 as possible. All right, so we are going to use this chart several times when doing these problems. Okay, so I would definitely know how to draw this chart. I would probably say you should be good up to 5. Okay, so you should be able to go up to 5 half-lives. All right, now, in order to solve these half-life calculations, there are 3 formulas that you need to know, but I like to think of them more as logic problems. Sometimes on the SATs, you end up seeing something like this. Okay, so when you're given your information, you're usually given 3 out of 4 pieces of information. And you need to figure out if you are given times or if you are given masses, right? Because that's going to depend on how you solve the problem. Okay, if you are given 2 times, you are able to figure out the number of half-lives that have gone by. So you take the time elapsed, which is going to be the bigger time on top, and the time of one half-life down at the bottom. Okay? If you are given 2 masses, you're basically figuring out the fraction that's remaining. Do you have 1/2? Do you have 1/4? Do you have 1/8? Do you have 1/16? So if you have 2 masses, the larger mass is on the bottom. Okay, the amount remaining here, and then you have the original mass right there. And you're going to have to figure out which one of these guys it's going to be. And then once you figure out either this part or that part, I cannot stress this enough. You have to use that chart on the previous slide. You have to make a correlation between the number of half-lives and the fraction remaining. And then you can apply the amount of the isotope remaining to the fraction and the original amount. Now I know that this slide is a little overwhelming, and that's why I like to think of these as logic problems and not as plugging into a formula. So we'll see how that works out. Okay? So here we go. Here's our first example. It says phosphorus 32 has a half-life of 14.3 days. How many grams of phosphorus 32 remain after 57.2 days if we start with a 4-gram sample? Okay, so what you should be able to do is use the units to figure out, did they give you 2 times or did they give you 2 masses? So I have 14.3 days, I have 57.2 days, and I have 4 grams. So they gave me 2 times. Okay, so if they put 2 times, you want to put the larger time on top. I really like alliteration. Time on top. Okay, so 57.2 days has elapsed, have gone by, and it's 14.3 days per half-life. So get your calculators out, push pause if you need to. Hey, you're back. And when you divide 57.2 days by 14.3 days, you get 4 half-lives. Okay, days and days cancel out, you get reciprocal half-lives, so that means 4 half-lives. So what you need to do now is in the corner of your paper, say what happens during 4 half-lives. 1 half-life, I have a half. 2 half-lives, I have a quarter. 3 half-lives, I have an eighth. 4 half-lives, I have a 16th remaining. Okay, so if I have a 16th remaining, okay, 1/16 of my starting 4-gram sample will remain. So how much is left? What am I doing here? I'm either doing 1 divided by 16 and then multiplying it by 4 grams, or you do 4 divided by 16 and then you get your mass. So it's up to you. So what happens here? How much are you going to have left? You are going to have 2.5 grams left. Another thing that you can do, which is really cool, is you can apply it to your little formula. Okay, if you start off with my 4 grams total, you can start to divide it in half. Divide it in half once, you have 2 grams. Divide that in half, that's 1 gram. Divide it in half again, that's 0.5 grams. Oh, I'm sorry, I put the wrong decimal here. And then you have 0.25 grams remaining. Oh, my bad. I'm so sorry. I see, it's really important that you check your work. All right, and you divide it in half and in half and in half again. So there are more than one way to solve these types of problems, and that's what's also really important to know. Okay, but some kids like formulas, some kids like a plan. So if you have 57.2 days that goes by, okay, 14.3 days is a half-life, so that means 4 half-lives go by. This is the crucial part. 4 half-lives is 1/16th, and 1/16th of 4 grams is 0.25 grams that remains. Cool, huh? All right, well, let's see what happens when we go the other way. A half-life example problem, okay? After 21.6 days, a 300-gram sample of nitrogen-16 contains only 37.5 grams of the isotope. What is the half-life? Okay, did they give me 2 times or did they give me 2 masses? Well, if you take a look, there are 2 masses right there. So if they give you 2 masses, okay, the heavier mass sinks. Okay, so that means this 300 grams goes on the bottom. So you have 37.5 grams that remain, and we have 300 grams originally there. So what fraction do we have left? Do you guys know how to solve for x? You have to cross multiply. So that means you have 37.5x equals 300 grams. And then in order to solve for it, you have to divide both sides by 37.5. So x is equal to 8. So I have 1/8 remaining, okay? Be very careful. You have 1/8 remaining, not 8 half-lives, okay? If you're dealing with grams, you're dealing with fractions. So just like we did on the other example, what is 1/8 equal to? So 1 half-life is a half, 2 half-lives is a quarter, 3 half-lives is an eighth. So this means 3 half-lives. You have to change, this table here is your conversion factor to half-lives and fractions. Okay? So that's really crucial to remember. So now what do we do? If 3 half-lives is going to be 21.6 days, how much is just 1 half-life going to be? So what I have to do is divide both of these numbers by 3. So 1 half-life is going to be 21.6 divided by 3. That would be 7.2 days. And that's how long one of the half-lives is going to be. Okay, so to see this all nice and typed out for you, here we have 37.5 grams, grams and grams. We're solving for x, so this means 1/8. Again, this does not mean 8 half-lives. This means I have 1/8 remaining, which is 3 half-lives. So if I have 21.6 days for 3 half-lives, if I divide by 3 for each one, I will figure out that I have 7.2 days for 1 half-life of nitrogen-16. And that's how we figure out half-life problems.